All right, everybody, so this is a video on phase diagrams and like phase changes. You really just need a piece of paper for today. If you have the paper I handed out with this graph, feel free to look at that. You can just draw this picture. I'll have all the notes online too to view if you want to look at them. So first I'm going to look at, this is what particles look like when they are a solid. If you remember, we saw this before, they are just shaking and it's adding energy. Now it's a liquid, lots of energy moving super fast. Every now and then a particle flies away, that is the gas. So we're just adding energy, and eventually everything becomes a gas. So this is a graph, so we should look at our axes to start. So on the bottom here, on the x-axis, we will see that this is temperature. Okay, and then on the y-axis over here, we have the pressure. Okay, so when particles have lots and lots of energy and a very low pressure, so nothing's really holding them together, but they're really hot, that is a gas. Okay, when they have more, that increased temperature, they're moving quickly. So here's a little picture, kind of like we just saw. So go ahead and draw that. When you increase the pressure, that's squishing them together, that becomes a liquid. That's this section of the graph here. So they are closer together, and they're still pretty fast, so I'm going to give them little swooshy fast lines. And then last section over here, this is the solid section. Solid, you can see here, is the lowest temperature, okay, just like ice, right? Ice is solid. They are moving pretty slowly. The lines in between are actually phase changes, and you guys should already know most of them. So what's it called when you go from a solid to a liquid? That is melting. So when you increase the pressure, you would go across this line, right? When you go from a liquid to a solid, that is freezing. So that would be lowering the temperature across the line. So this whole line here is called the melting point line. So things can melt at different temperatures. It just kind of depends on what the pressure is. So based on the pressure, you can see when it melts. Liquid to a gas has a bunch of different names. It's called anything from evaporating, or it could also be boiling, or it could also be vaporization. So vaporization, I think people are at least familiar with, but a vapor is just a gas. So anytime you see vapor, gas. Okay, and then gas to liquid, okay, that is like rain, that is condensation. And the last line, again, this is the boiling line. That's the whole line's called. All right, last line over here. We talked about this earlier in the school year, but you guys probably don't remember. Solid to gas is called sublimation. So that is kind of like dry ice. It just skips the liquid. And then gas to solid is called desublimation. All right, so those are all the different lines on the graph there. We should also define what is pressure and like what is temperature. How is that defining these different spaces here? So pressure is basically just when particles are colliding with walls. So every time the particles are moving and hitting each other and hitting the walls, that is more and more pressure. The symbol for pressure is P. And there are a bunch of different units for pressure. It can be measured in ATMs, which stands for atmospheres. It can be measured in kPAs, which is kilopascals, or it can be measured in torr. Those are just all the different units you'll see for pressure. Okay, and what about temperature? So temperature is the average kinetic energy of particles. So we remember this, right? Kinetic just means movement. So it's how much the particles are moving. So if they're moving really, really fast, that means that it's really, really hot. Okay, if they're moving really slowly, that just means that it's really, really cold. Units on temperature here is going to be degrees Celsius, or capital K, which stands for Kelvin. And one other thing I just want to add here is that a gas can also be called a vapor, like I said before, but just make sure you write that on this graph too. The gas can also be a vapor. So last two things on this graph that we have not talked about yet are these two letters. So the first one is T, which is right here on this graph. Let me give you a different color so you can kind of separate it. So this is T. T stands for the triple point. As you can see on this graph, all three are connected on that little point. So this is when a substance is a solid, a liquid, and a gas, all at the same time. It's called equilibrium. So any of the lines represent equilibrium. This one is equilibrium between all 3 points. And I realize you guys have probably never seen anything like this before, so check out this cool video of a substance. So you can see here that it is frozen on top, liquid on the bottom, and then every now and then you'll see little pops. Okay, and that's the steam. So bottom is liquid, top is solid, but it's also boiling. So it's boiling and freezing and a liquid all at the same time. So this is called a triple point. Pretty cool. All right, so last part of this graph here is going to be the C. I'll use a different color for this one too. All right, so C stands for the critical point. And at this point, basically it is just so hot, there's so much temperature, and there is so much pressure that the substance is not sure what to do. It's really when it is both a liquid and a vapor at the same time. Okay, it's a liquid and a gas. We can't separate which one it is. It's just both. So when we look at this graph on the top over here, this whole area is just both. That is the critical point area. It is a liquid and a gas at the same time. All right, so last thing for our notes here, I know you don't have this picture, but I just want to show you some different kind of questions you might see like on the homework sheet. So the first thing, of course, you're going to have to do is label different areas of the graph, which is pretty easy. This is the vapor, the liquid, and the solid, just like we had up there. You'll have to label where the different lines are, like this is the boiling point line, and where's the melting line, and that kind of stuff. Just look at the notes, and the labeling should be pretty easy. Some questions will also ask you what is the normal melting point and what is the normal boiling point. So it can melt anywhere along this melting line. So over here, this red space, this is the whole melting line. So any point there, it can actually melt, but it wants to know what is normal. So normal is just when you look at the pressure, it will either be in ATMs, it'll be 1 ATM. So like this is, this graph is in ATMs, but in your guys' homework, it's going to be in kPAs. So just look on the side of the graph there, and it'll be 101.3. Okay, that'll be for the homework. So you just find that on the graph. So on mine, it's going to be 1, and you find where does 1 hit the melting line, and whatever temperature that is, that will be the answer. So for this one, the normal melting point is going to be 0 degrees Celsius, which makes sense because that's where water will melt. Similarly, it'll ask you what is the normal boiling point, which is essentially the same thing. You're just looking at the other line. So again, it's still normal, just means 1 ATM or it means 101.3 kPAs. So on my graph, it's ATMs. So I'm going to find that 1 ATM. And where does that hit the boiling line? So you go across, hit the boiling line, and then go down. And that is where it is going to boil normally. So for this answer, it is 100 degrees Celsius. So you guys just need to make sure you're looking at 101.3 because your graph's going to be in kPAs. Any questions you have, feel free to post online, email me. We will figure this out. Just get your homework to me any way that you can. And yeah, sounds good. I hope you guys have a super awesome day.